Firstly, thank you for that warm welcome, and I'd like to thank BAI Kochi for inviting me to speak at this esteemed occasion. I'm going to do my best to cover a lot of what we do in the construction business. I'll start with a quick background. I'm not a civil engineer, I'm a computer engineer. And the reason we got into construction was we were struggling to retain our staff in the software business. And one of the incentives that we came up with to kind of retain staff was to giving them a free home. And that's how we got into construction. And once we got into construction, I think the key thing I'd like to touch on as I go through my presentation is what I realized after getting into construction is there's a significant difference in culture between the software industry and construction industry, say, primarily because of safety and soundness of construction buildings and residential commercial properties that are put out there. But I'm going to share with you our journey in Cochin. So our unit for software is based in Infopark, Kakanad. So we have our own campus in Infopark Phase 2. And then we got into the construction business in 2012. So So, firstly, like the introduction, we are our primary business is software and technology. We are also into financial services solutions in the US. So we provide a lot of software solutions for the large banks and financial institutions in the US. And on the construction side, we are into residential and commercial construction. And then we are also into healthcare, both from a family medicine and behavioral health standpoint. So the question is, why is a company like this getting into construction? And I'm going to get into that in a little more detail. So just to provide the background of what are we doing in construction. So out there, that's our campus built in Infopark Phase 2. The facade of the campus is solar panels. So you heard some of that discussion today. So we produce 30% of our energy from the facade of the building itself. And then on the right is our US campus in Cincinnati, Ohio. Now, what have we already done? So we delivered our first residential building in 2017, 2018. This is next to Infopark in Kakanad. It's in a place called Pinarmunda, 15-story high-rise building. And all the apartments in this building, all 3 bedrooms, they're all centrally air conditioned. And I'm going to touch on, I think the key part of my presentation today is energy efficiency and sustainable construction. So I'm going to touch on the technology that went into that building. Now, again, we continue to build residential projects in Cochin. So this is a project again coming up in Palikara. That's our office building. Like I mentioned, the office building in Infopark has a solar panel facade, has R20 insulation, and a lot of specifications that I'll touch on. We also do centrally air-conditioned villas. These villas are again in Kakanad, Kochi. We do traditional centrally air-conditioned homes as well. This is one of our corporate guest houses that we built. And we also do innovative homes. All of this is in, I would say, in Ernakulam and Alapi district in Kerala. So what are we talking about here when we talk about energy efficiency? I think the most interesting thing to start with would be the results and benefits. And I'll touch on the results and benefits because after I get into the technology, at least you can relate back to what is the purpose of doing this. So the results are, firstly, we are seeing an 80% reduction in energy utilization. So when I say that, just hold that thought because I'll explain how we are achieving it. Because when we launched our project and we delivered our project in 2018, we were thinking this is going to catch on like wildfire. Everybody's going to do this because it makes so much sense. It's been surprising to us that it has still been slow. One of the reasons I was thinking it's going to be interesting to come and present here is just to kind of explain what's behind this. So how is this even possible? Okay, so hold that thought. Second thing is just to give you a sense of the practical outcome, we are delivering all our apartments are 3-bedroom apartments, like 1,700 plus or minus square feet on average, centrally air conditioned. Every apartment is cooled with a single 2-ton AC. So we use a typical ductable 2-ton, 2.2-ton unit, running the entire apartment at, let's say, 24 degrees for 24 by 7. So the living, dining, kitchen, and 3 bedrooms, the air conditioning is not switched off ever. your monthly consumption is actually less than 5,000 rupees. So that sounds very unbelievable, but I'm presenting the benefits because when I tell you how this is achieved, you should be able to connect the dots on why is this possible. Like I mentioned, the actual tonnage, this itself, when we call the technicians to set up the unit, they can't believe that we are cooling a three-bedroom apartment with a 2.2-ton unit. And so it's interesting, and I'm going to share the data, and I'm going to share what is happening elsewhere in the world, so you can understand that there's something missing in the way we are doing things here. Nothing we're doing here is innovative or new inventions. This is just doing what is established standard practices in other parts of the world. Again, you can see the moment you reduce the HVAC tonnage, your connected load to the utility for energy is also significantly low compared to what you would otherwise have to address. So you're talking about 8 to 10 tons of air conditioning for a three-bedroom apartment, and we are able to do it with 2.2 tons. Okay. So those are the results that we are achieving. Let me get into what's making that possible. So in this building, uh, all the apartments in the building, if you notice, it's floor to ceiling glass facades. And glass facades are not ideal when you're talking about a centrally air conditioned residential unit, as you can imagine. But in spite of that, we are able to achieve the efficiency that I touched on. Now, just a few visuals from the interiors here. So all the apartments have ducted air conditioning. So this is typically what you see when you travel the world. These are not split units. These are not VRF units. It's ducted air conditioning across the apartment. We have dampers for each room. So you can, even though it's a single unit supplying the air conditioning for the apartment, you can regulate the temperature of each room as well, or switch off certain rooms, like switching off the bedrooms during the day or switching off the living, dining, kitchen during the night. Floor to ceiling glass facades, like I mentioned. Uh, the design aesthetic that we've gone with is contemporary design because that's what we see our clientele looking for because we are next to Info Park. Open plan kitchen, and we have a closed work area as well. All our buildings, we have our own building automation. So as more and more technology is getting into construction, the biggest challenge with home automation or building automation is the ongoing maintenance. Typically, if you buy a product, it's outdated or obsolete in 2 to 3 years, and many of you might have seen that. So we designed it in a manner where it's parallel to a dual switch for every appliance in the house. And it also helps us regulate a lot of the technology around the central air conditioning inside the home. So, how are we getting 80% energy reduction? So, I'm sure there's a lot of curiosity as to how is this even possible. So, let me get into that. So, firstly, insulation. So, the best way to explain it is the US standard, if you look at Arizona, Florida, across the Midwest, for energy efficient residential buildings, which is in the building code, is R20 insulation. So, R value is simply the measure of insulation, just like you have centigrade or Fahrenheit for the measure of heat. R value is how you measure insulation, which is heat transfer. So what we are doing is all our buildings have R20 insulation built into the product. It's in the walls, the ceilings, the floors, all the slabs. So I'm going to get into that. And insulation is what delivers this impact for energy efficiency. So to kind of relate to it, the best way you can visualize this is think of your refrigerator at home. So the refrigerator you have at home, the compressor is running for less than 1 hour out of 24 hours. Uh, why is that? Because you have the puff insulation on all 6 sides of the refrigerator, and your compressor will only run a little extra if you keep opening and closing the door. But if you keep it closed, your compressor is running honestly for less than maybe 30 minutes out of 24 hours. Because once it cools a space, because of the insulation, the energy, the heat doesn't transfer through that puff insulation. So conceptually, that's what R20 insulation does for a residential home or for a commercial building as well. So the R value basically measures, and all of you would have studied this in school or college, or you're familiar with the concept, right? It's the transfer of heat from one space to the other is measured. The ability to withstand that transfer of heat is measured in R value. Now, obviously, when you have R20 insulation, the comfort or the ambient temperature is significantly better, even without the air conditioning. So all of you know if you go into a traditional house built with wood, and terracotta tiles, it feels a lot cooler than a concrete brick construction or an RCC construction. And that's because the materials in traditional construction with wood and terracotta tiles has a higher insulation property or an R value. So similarly, what we've noticed is the moment you go with that approach, you have comfort even without the AC unit being switched on. And we've noticed this with the construction workers on our sites, because they feel like it's interesting. This building doesn't feel as hot and humid as the other buildings. And finally, there's noise reduction. So when you're using R20 insulation, it also acts as a dampener, and then you have better noise control. And this is important, especially for commercial buildings. So practically, it is literally this simple. If we can use a high grade of insulation within the space, the results are exponential. The question is, how do you do it? Like, how do you incorporate this in a manner where you can control the cost, make it practical, and also make it utilitarian for your customers? So I'll get into that. Again, just to refresh everybody's minds about heat transfer, there are three ways in which the heat moves around. You've got convection, conduction, and radiation. Radiation is how the energy from the sun reaches the earth. And blocking all three is the ideal state of insulation. And that's how you achieve the key goals of meeting your energy efficiency requirement. So, again, when you talk about insulation, there are different types of insulation materials. Many of you are familiar with all these types of insulation materials, but practically, the way you look at it, what's available in the market and what is practical to use is you've got polyurethane foam, which is puff. You've got styrofoam thermocol, which is polystyrene foam. That's a second grade. And then the third one is fiberglass or fiberglass matte insulation, bat insulation. So those are and you can, when we were talking to some of our real estate clients in the software business in the US, they couldn't believe that in India we have commercial construction and residential construction with air conditioning, but without insulation. Because they were like, no, that can't be possible. And in fact, one of them said, if you're saying, if what you're saying is true, that is like having a refrigerator without insulation. And I was like, okay, that makes sense. So, and they were suggesting, I'm sure in India they must be using wood mulch or dry leaves. They couldn't wrap their head around the fact that we have absolutely no type of insulation for residential spaces or commercial spaces that are air conditioned. Now, again, just to give you a sense of what is this R value concept, you hear the debate about red brick is better than concrete blocks, or you can have hollow blocks that are better than solid blocks. But if you look at that, you look at the R value of those materials, those R values are very marginal. For example, a red brick wall will have an R value of 0.8. The higher the R value, the better the insulation. So if you come all the way down, wood obviously is a better insulating product. And then you come all the way down to fiberglass, polystyrene foam, or polyurethane. You can see just what we use in our construction is styrofoam, which is polystyrene foam. 1 inch of styrofoam is having an R value of 5. So just to visualize that, 1 inch of styrofoam is having the R value of about a 3 feet thick wall. And we use 4 inches of styrofoam. That's how we meet the R value of R20. And to achieve that using a brick wall, you'd have to have like a 15-foot thick wall. And if you visualize it, when you go into a cave or if you go into a deep space covered by solid rock, you feel cool because of the thickness of that material. So again, very simple stuff here in terms of understanding what that means. So what does this mean practically? And if I go to the next slide, practically, if you do a Google search and just look at the air conditioning square footage for the United States. So what you see on the US web map there, the lower states like Florida, Arizona, Texas are the warmer states. And if you see the air conditioning tonnage specified in their code, it's like 1 ton for 600 feet or 600 to 1,000 square feet. If you talk to your HVAC engineer or technician in India, they will recommend 1 ton for 120 square feet. So this is not rocket science, right? And a simple Google search can give you this data. And if you have friends in the US, just ask them to check the tonnage of their AC unit. It'll be 2.5 tons to 3 tons for a 3,000 to 4,000 square foot villa or a significantly large apartment. So that's the physics or the science behind the whole thing. So if I've aroused your curiosity, let me touch on how are we constructing these homes. So practically, how are we achieving this level of energy efficiency in the homes? So I spoke about the benefits. I spoke about the materials we're using. Let me give you a practical glimpse of what we are actually doing on the site or how the technology is being applied on the site. So all our partition walls, for example, when we are putting up an apartment, whether it's a villa or a multi-story residential building or a commercial building, all our partition walls are 4 inches of styrofoam with weld mesh on both sides. Now, if you go to the market, you also get what are called 3D panels, which are styrofoam panels with the weld mesh already integrated into the panel. But we were doing this from 2014. So our approach has been just to get the weld mesh and adhere it to the styrofoam panels and then just cement render or cement plaster around it. So that's how we do our partition walls in the building. So the important thing to understand is now in any room, all the four sides of the walls are all now insulated with R20 insulation. So the question then is, what about the ceiling? What about the slabs in a multi-story building? So this is where I think we innovated a little more. So all our residential buildings have integrated styrofoam in the slabs. So this is an RCC frame structure. We still have the same RCC columns. We still have the same RCC beams, but all the partition walls, the external walls, the internal walls are styrofoam mesh integrated. And we have a 30 centimeter depth in all our slabs, and we are able to get spans of up to 7 meters as well. And we use a mesh at the bottom, mesh on the top, 8 inches of styrofoam with 2 inches of concrete at the bottom, 2 inches of concrete at the top. So the actual insulation property of our slabs is R40, which is even more than what we use in the walls. And we pass the building code because technically this is a waffle slab, as all of you know, a waffle slab with an additional tension bearing slab at the bottom. So we get the code cleared because it passes all the calculations for a waffle slab construction design. So, from a practical standpoint, that's what we are doing to achieve insulation in the residential building. Now, uh, another interesting aspect to HVAC or air conditioning efficiency and energy efficiency is the thermal mass of the building. So, what is not being looked at is and when I look at this, it's interesting to observe that when you increase the mass of the building, you're actually increasing the energy sink to suck the heat during the day. So think of it like you go to a tattukada where you have a dosha stone that's 1 inch thick. It takes a long time for that to get heated up, but it's going to retain that heat and exude that heat. Well as what you make doshas at home on, which is an aluminium tawa, is a very thin aluminium, low thermal mass product, which in 10 seconds will dissipate the heat. So, what's happening in our homes today is with very large designed structural sections for slabs and beams and all, it acts as an energy sink. So, during the day with 30 degrees of temperature outside, the building is absorbing that heat energy, storing that heat energy, and then radiating that heat energy internally. You can do an experiment at home today. Just before you switch on your AC unit at home, just take a temperature check if you have the infrared thermometer of the wall, and you'll notice the wall temperature is around 30 degrees. Switch your AC on, let it run for 12 hours. The next day morning, check the wall temperature. It would have reduced by 1 degree. Because that's what we were testing, because there's so much of heat retention in the thermal mass of the structure itself that the compressor of your air conditioning unit does not have an opportunity to switch off. And then I don't want to spend too much time getting into the science of HVAC and ambient air temperature, but it's not just about reducing the temperature of the space. You want to do the humidity control. So humidity control is about air circulation and sucking the humidity from the air. So in most residential units that we visit where the customer is retrofitting the unit, they are putting a high powered unit expecting that to be better. But when you put a high powered unit, it cools the space very quickly, but it's not circulating the air enough to suck out the humidity. And So actually reducing the thermal mass of the building for all the structural engineers here is an interesting challenge, but is one of the key factors that also impacts what we're doing here. So to give you an example, I mentioned my slab is 30 centimeters depth. We are still trying to deal with the 2 inches of concrete on the top and the bottom because it still acts as a thermal mass that absorbs energy. But what we've noticed is that's a key factor to keep in mind outside of just the insulation, because there's no point in having your insulation and then layering mass around it. That defeats the purpose because it's going to absorb the ambient temperature and radiate it back internally. So, what are the sustainable benefits of insulated walls, ceilings, and slabs? So, the first thing is 70% reduction in the dead load of the building. So, just think about this. In the slab, you're taking out 80% of the mass because your styrofoam is as good as air, right? So otherwise, you would have in that neutral axis, you would have concrete, which is very heavy. And if you're using brick wall uh, or any kind of panel, even if it's a prefabricated concrete panel, it's still heavy. When you replace that with 4 inches of styrofoam for the walls and 8 inches of styrofoam in the 12-inch slab, you significantly reduce the weight of the building. So, what is the benefit of that? There's significant benefits, as all of you can imagine. Your foundation costs can come down dramatically because, again, depending on the how the structure is designed, you could reduce it by 80%. In fact, I'm going to get into what we are doing with composite materials as well. So it was interesting listening to Mr. Anupambika in the morning talk about the opportunities with composite materials because that's where we are heading next. But to touch on foundation costs is an easy win. Increasing seismic resistance. So if you think about it, the center of gravity of a high-rise building is very critical from a seismic resistance standpoint. So when you reduce the mass of the building, the horizontal forces that act on it in the seismic resistance calculations is significantly less. So for example, just to visualize this, by reducing 70% of the mass of the building, a 10-story building only has the mass of a 3-story building. So it impacts your seismic calculations and actually your seismic safety exponentially. So again, we have modeled this even in the software, even for a 100-story building, and the wind loads, seismic resistance is all exponentially better. And like I said, lastly, it reduces the thermal mass. So especially in our country, especially in the south of India, because of the weather here is hot and hotter, right? We don't have a winter as such. It's just hot and hotter, and it's generally always humid, even during the rainy season. So reducing the thermal mass, what we have seen is even without the air conditioning, is significantly more comfortable. So that's an obvious key benefit. And now I'll get into the sustainable side. So one is the energy efficiency side. To talk about the sustainable side about using technologies like this in residential and commercial construction, the first thing is the opportunity to recycle styrofoam. So many of us don't realize this, but the highest material by volume in any landfill or any garbage dump is styrofoam, and because it's not an easy material to recycle. Again, just sharing some statistics, a huge quantity of styrofoam is produced all over the world every year, and it fills up our landfills, waterways, because it's a light material, it's a petrochemical product, which means it's plastic, so it doesn't degrade, and it's always available in the system, in the environment, so that's a huge problem. Uh, 14 million tons of styrofoam are produced each year around the world because it's used as a packaging material. As you know, pretty much any product you buy, electronic product, electrical product, it gets packed with styrofoam. The Americans themselves throw away about 25 billion styrofoam cups. So this is like we talk about single-use plastics. Styrofoam is again an example of a single-use plastic. 30 to 35% of everything that goes into the landfill is from styrofoam. Is styrofoam because it's high volume, very low in weight, and material that doesn't degrade. So most of the landfills, 1/3 of the volume of those landfills is actually styrofoam. 40% of the styrofoam out there is actually produced from food waste. As you know, you go for any function, a lot of the plates and packaging materials are styrofoam today. Styrofoam in the landfills is exuding methane gas, which is 20 times more than the carbon dioxide emissions. And it's just accepted because there's probably nothing much that can be done about it. Uh, it breaks down into small particles, gets into the food system, especially into the oceans and lakes and rivers, and becomes a problem once the fish start ingesting it. So I'm sure all of you can relate to this. It's a plastic product, so it's got all the negative issues of plastic. Styrene, which is the chemical component in polystyrene, is a harmful chemical that also leaches into the food if it's left out there in the environment for a long time. So, where I'm going with this is if you're just like waste plastic today is recycled into roads, right? Because nobody cares if you mix any grade of plastic into the road and make the road more durable. When you start recycling styrofoam, it doesn't matter what grade of styrofoam you use. It doesn't matter whether there's a little biryani on the styrofoam also because it's being sandwiched into the panels. So you don't really need high grade virgin styrofoam for construction. Now, all our construction till date has been done with virgin styrofoam, but in our vision, we want to go to the next step and reduce the cost further by 30% by recycling styrofoam. And just to visualize this practically, if you take styrofoam, break it into small pieces, and just steam it in a puttugutti, it'll fuse again. So you can very easily recycle styrofoam, especially for this purpose in construction. And today, less than 1% of styrofoam is actually recycled. So it seems like the ideal product that could be deployed en masse in the construction industry, especially in India, given all the benefits that I touched on. So finally, like I said, I'm going to just touch on energy efficiency again because you talk about the energy efficiency in the country. Uh, when you think about a residential home, if you do not have air conditioning, your monthly electricity bill might be 1,000 rupees to at most close to below 2,000 rupees a month. The moment you put one air conditioner in one bedroom, your air conditioning bill now goes to an additional of 5,000 rupees. And then if you put air conditioning units in the entire home, you're talking about 30,000 plus only if you use it sparingly. If you use it 24 by 7, you're going to see an insane power bill. And as all of you know, when we are delivering units to our customers, every customer can afford to buy the air conditioning unit. What they cannot afford is the energy bill at the end of the month if they use it continuously. So 75% of the energy consumption in the residential spaces for air conditioning in the country. The impact of insulation is saving 85% of that. So you're able to reduce the energy, like I just gave you the statistics that we have seen. 85% of that energy consumption can be reduced while you still get your air conditioning if you incorporate insulation into the design and construction of your buildings. Where is this going? 70% of the energy bills can be saved using insulation. So now, not only are you making it more efficient for the utility of the space, but you're reducing the operating cost of the ongoing expenditure for the customer through that savings. And what are you doing for the utility companies? So utility companies have a major issue with peak load. As all of you are familiar with, we've not seen it very often of late, but this whole concept of power cuts and such is because they cannot handle the load during peak load, and all that peak load is going towards air conditioning. 85% of their energy can be reduced if you have insulation tied to it. So next I'm going to get into prefabricated housing. So what I've touched on so far in my discussions with the BAI team, they just requested just come and share your experience and share what you've done. But now we are going to the next stage. So to just share some information here, composite housing or prefabricated housing obviously is a big deal in India itself, but in the United States is an even bigger problem. If you go to the Midwest, which is the lowest cost part of the US, if you go to the East Coast or West Coast, it's much more expensive. But in the Midwest, for a basic standard residential home, the cost is $250 a square foot. So $250 about more than 20,000 rupees a square foot. Our cost in India is about $35 a square foot. So now we are working on, with the city of Blue Ash, we're working on a program to get the building code certified in the US for prefabricated homes from India. So we're fabricating it here, shipping it in 40-foot containers and doing the assembly in the US. So what does that mean practically? So I'm just going to show you. So to get the fire department tests done and the building code approvals, we had to ship a sample. So I'm just going to show you the assembly of a sample structure that we had to send to the US, so you can visualize this. So what you're seeing them assemble there are all fiberglass FRP foam core panels, and the panels integrate the conduits for the electricals, integrate the plumbing for both supply and drainage, all interlocking with tongue and groove joints, silicon sealant for uh, sealing them. And in about, this is a time lapse video, but in about 15 minutes, this is like a small test. It's like a 30 square foot structure, but in 15 minutes, the whole assembly is done. And and the whole idea is if we can significantly reduce the labor cost or the labor involved in fabricating these homes on site in the US, once the containers are shipped there, we just need to do the final assembly. And then we use wallpaper, or you can use any textured paint for the final fit and finish. Just a view of, just to visualize what we mean by composite prefabricated panels. So this we feel is going to be the future, because the weight is now reduced by 95%. So just to visualize this, a 100-story building would have the actual mass of a 5-story building. Because when you're using fiberglass with foam core, there's again, when you go back to your basics of civil engineering, you've got concrete delivering the strength for compression and steel delivering the tensile strength. In composite construction, the tensile strength is delivered by the glass fiber in the fiberglass, and the compression is delivered by the resin in the fiberglass material. And then wherever you want stronger structures, you can use carbon fiber and such. Now, getting building codes approved is a big issue. We are trying to do it in India, but as you heard from the speakers earlier today, it is challenging and time consuming. We feel we'll get it approved faster in the US, and then maybe we can bring it back to India. We are working on a project, however, in the Maldives. The Maldives has like 500,000 people, and they can get things approved very quickly. So just to give you a visual of that project, so we are working on this water villa design for the Maldives, fully prefabricated with FRP panels manufactured here and shipped to the Maldives and assembled there on site. This is currently a project that is undergoing, that is being executed. Even the swimming pool is fabricated and molded with FRP. Just the visual. Just to visualize what those panels are. So the base of the that particular structure is again 12 inches in depth, or 30 centimeters in depth. So all the plumbing, the commode plumbing, the drainage, all of that goes through the base plate, the FRP panels. The vertical sections are all load bearing, because we don't need rebar, we don't need traditional columns. The FRP panels itself are load bearing. And we just fabricate these panels, interlock with tongue and groove joints. The ceiling panels in this particular design are again just flat panels, but we are able to fabricate in any shape, whether you want textures like a tiled roof or whatever. And then the final structure is entirely FRP. Once you have the final structure, then what we're doing there is the final finish, which is just silicon sealant, wall putty, and then you can put traditional tiles, or you can put composite interlocking tiles for the flooring, any kind of texture, wallpaper, or paint for the walls, so on and so forth. Just a quick visual of all the panels that get fabricated, so you can visualize how that design is done. And all these panels are fabricated in our factory, and then we assemble them on site for the final finish. So one of the things I think I started out by saying is, I think there's a cultural difference, because even I have thought long and hard, why has approaches like this not really caught fire? Why is it slow? We have lots of builders and contractors who come to our site, because when you see the building up there, the whole building looks white because it's styrofoam, right? They're like very curious. At one point, we were the largest buyers of styrofoam in Cochin, because the supplier did not know what we were using the material for. So the interesting thing here that I would like to share is, I think there is a cultural difference for good reason, right? Because when you're designing a structure, you cannot afford to take a risk, because if one building has a structural issue, the career of that structural engineer is practically destroyed. They'll have to move to a different state or a different country because of the reputation issue. So there are very good reasons why in the construction industry you have to be very careful and you have to be very safe and secure with any changes you make. So one of the other things we heard today was changes, right? The resistance to make changes. What I will share with you is just a cultural thing in the software industry, which is my bread and butter. The software industry culture is very different because the technology is changing literally every 2 to 3 months. And if you do not keep up with that change, you're not going to survive. And I think some of that culture has rubbed off on our approach to construction as well, because we are not compromising on safety and security. And I guess the best way to visualize it is even in a high-rise buildings, when I get the question, I would ask you to visualize a government water tank on the side of the highway. A government water tank on the side of the highway might be a 10-story, 15-story tall building. And what do you see in the structure? You see the columns, you see the beams, but you don't see anything for the slabs or the partition walls, right? And then you have this huge load-bearing tank at the very top. So our entire residential building or commercial building is actually like that government water tank because the structure is still RCC, but we have just innovated on all the other aspects of the building to get the energy efficiency that I touched on. So I'm going to leave you with a small little video which really helped us a lot in our culture in the software industry, because when we are recruiting staff and trying to get them trained and getting them to be open about innovation, one of the lessons we have learned is until and unless you are open to wanting to innovate and wanting to change and deliver better quality product to the customer in the software industry, we will not survive. Things are not going to work. So this is one of the things we try to use in our HR training and staff onboarding process. I thought I'll share it with you. It's a small short video about the challenges we have in our mind in questioning established norms and assumptions. So let me just get into that. Let me see if it'll play.
A scientist placed 4 monkeys in a room with a stepladder upon which there was a bunch of bananas. Whenever a monkey went to climb the ladder, the other monkeys in the room were sprayed with cold water. After a while, each time a monkey went for the bananas, the others would attack it to prevent it from doing so. The monkeys learnt to never climb the ladder. But then, one of the monkeys was removed, and a new monkey wearing a raincoat was introduced. Naturally, this monkey went for the bananas, and it was customarily attacked and prevented from doing so by the others. This new monkey learnt not to climb the ladder. So when another monkey was substituted in and made for the bananas, all the others attacked it, including the one in the raincoat, despite the fact that it had never been sprayed with cold water. A third monkey was substituted in, and then a fourth final monkey. And still, whenever a monkey tried to climb the ladder, the others would prevent it from doing so, even though none of them had ever been sprayed with the cold water. When asked why this was, one monkey said, "That's just the way it is."
So the key takeaway there is what we've also seen in our software business is that the technologies that exist today and the way we do things that exist today has been built over the last 50 to 60 years. And nobody is questioning the legitimacy of those rules in today's modern world, right? So if you go back 50 years, there would have not been any styrofoam. You would probably not be able to find a weld mesh. You wouldn't get the grade of cement or concrete that you grade today. So it would not be possible 50 years ago. But today, when you think about it, if you apply this concept of first principles, which is questioning every single assumption, you can take things down to the basics and try to apply the technologies that have evolved over the last few decades and see, is it practically applicable for each layer of the problem you're trying to solve? And that's when you end up with an exponentially better solution. So we have seen this to be successful, obviously, in the software industry. And interestingly, we are seeing it to be successful in the construction industry as well. So, just happy to share. And I have a few more minutes. I have one last slide, and then we can open up for questions. So, why is a technology company getting into construction? I always get this question as well. Aren't you happy with technology? Your margins are better, And do you really want to get into construction in Kerala because of all the perceived issues? honestly, we've not seen any issues. We got into construction in 2012. We do have the traditional issues that all of you are aware of, but these are all issues that you can work through and solve. But what we are seeing is that the home is like the future of the smart. Just like you had a telephone that did one thing, make a voice call, and today with the smartphone, that device does everything. We are seeing the next target is the residential home. The residential home is going to be a smart space that is going to be demanded by the customers. And you can see with Alexa, Google Home, and a lot of the home automation technologies, it's already being demanded by customers. So our vision is the home is going to be a space that can use a lot of technology and software. You have technology in the home. So if you think about the builder delivering air conditioning to the customer, you need to be able to support it. You need to be able to maintain it. You need to be able to manage it. If you're delivering building automation and home automation, you need to be able to support it and maintain it. So technology is getting into the house. It's no longer just a civil mechanical structure. It is intelligent space. Central air conditioning is a given. The best analogy I bring up with some of the senior folks I meet is, if you remember the days of the Ambassador and Fiat, you buy the Ambassador, then you take it to Coimbatore to put a Matador diesel engine and then change the seats and put an air conditioning unit and then put a sticker on the back of the Ambassador saying AC car, right? Those were the days that existed. You fast forward to today, the cheapest car in the market is air conditioned, right? So it's just interesting that air conditioning is not a default feature today in commercial and residential buildings. And in our case, I mean, we have the data for the last 6 years, and still people don't believe it. So that's interesting. And I think, only if some of the bigger brands start doing it, will there be more credibility out there with the consumers. Because central air conditioning, I think, is a given. And when the builder gets into central air conditioning, you need to have the technology capabilities to support and maintain it for the customer as well. And that's what the customer wants, because the customer has no idea how to deal with this stuff. Sewage treatment, wastewater management, these are all getting intelligent and smart. So you need to have the ability to integrate and manage all these systems. So, and then finally, energy efficiency through captive renewable sources like solar or grid connected systems. Again, it's all technology that needs to be maintained and managed by somebody. And as all of you know, the building association is not the right entity to figure this out because it's going to be a mess, right? So I hope this was helpful for everybody. I tried my best to cover a lot of ground there. We have time, so I planned with the BAI team to make sure that there's time for questions. Yeah. Thank you. So I can take any questions if any of you...
Just one part. What happens to the styrofoam when you take down the buildings?
You can recycle it.
You can recycle it completely.
Because if you break the building down, it's a plastic material. So, and styrofoam, just like waste plastic, you don't need virgin styrofoam for this purpose.
Okay.
So you can recycle it. We've not reached that stage yet. But even when we are constructing, there is a lot of waste styrofoam, because when you go to the edges and you cut it and all that. So we are already recycling the waste portion of the styrofoam that we are purchasing.
Got it.
So even if you demolish the building, same thing. Yeah.
Do we have more questions?
Yes. So glass already. So I think the question was, what about the heat transfer to the glass? So there's a lot of options today with glass, with double glazing and also the UV resistant glass coatings that are available at Saint Gobain and the others. And some of the suppliers are already in this room. So you already have very good options to prevent heat radiation getting into the building from glass. In addition to that, the only way to protect against radiative heat is a reflective coating. So you can get curtain materials today with aluminum surface coating that reflects 97% of the radiant heat as well. So what we do is we have a sun curtain. We also have a blackout curtain in addition to the reflective glass. And double glazing is another option. Double glazing is also important because of condensation. When you have air-conditioned spaces, if you do not have a double glazed glass, you'll have the sweating and moisture on the glass. So yeah, good question.
See, you had told about the reduction in weight by 1/10. So when it comes to high-rise buildings, see, the wind load calculation is based on the self-weight of the building also. So how do you manage that?
So you have alternate options. So if you look at how you design your building structure for the stress-bearing options for a high-rise building, I would say the best example for a truly high-rise building, how it resists wind shear is if you go to YouTube, just look at the structural design. It's like a short video on the Burj Al Khalifa in Dubai. So you'll see how that design is exactly. So they have in the structural elements of the building, the lift vestibule is like a backbone, and then they have other just like the I-beam. You have the two flanges. They design the structure for those stress factors and for wind shear. Same thing. Because when you reduce the mass of the building, yes, you lose that advantage for wind shear, but then you can counter the wind shear through other design options. Yeah. I mean, we've modeled the prefabricated composite panel buildings, we modeled it to 100 stories in the software. It's interesting because if you think about the sports pole vault, the pole vaulting pole is a fiberglass pole. So basically, that entire structure acts like a ductile structure. Great. Thank you so much. Thank you for having me this evening.
Thank you, sir. Good evening to all. We would like to extend our heartfelt gratitude to Mr. Vinod Tharakan. His insightful presentation has not only enlightened us, but also inspired us to push the boundaries of innovation and sustainability. His commitment to energy efficiency and sustainable practice is a testament to his dedication for a better future. As a token of our appreciation for his valuable contribution, we would like to present him with a memento. Hope it serves as a reminder of his impact on our BI community at a global stage. On behalf of BI Cochin, I request Mr. Vinod Tharakan to collect the memento from us.
I request former State Chairman Sri Prince Joseph to give a small token of appreciation and gratitude to our speaker, Mr. Vinod Tharakan, on behalf of BAI Cochin Center. Sir, we're delighted to present you our traditional Aramula Kannadi, a cherished symbol of heritage and craftsmanship. And also a custom created caricature thoughtfully designed for you. Thank you, sir.